Hi, I'm Chris Madison with Fermyon. Today, I'm going to talk about building a Slack bot to connect Slack with ChatGPT. If you'd like to follow along with our example live today, you can access the GitHub with the app and all the steps right here. First question you might have, though, is why? Slack just announced native integration with ChatGPT. There's a wait list, but you'll get it eventually. Well, today's webinar isn't as much about what is the only way to connect these two technologies, but about how Spin provides an ideal architecture to develop and run these and other types of applications. Spin allows you to build applications in the language of your choice, eliminates boilerplate, it combines the performance of always available architectures, such as containers or virtual machines, with the density and cost savings of serverless functions. How do we do that? By leveraging WebAssembly on the back end. You can think of Spin as being powered by Wasm. WebAssembly provides a highly performant, natively secure environment, which supports most popular languages and can be compiled into bytecode that can be run anywhere across x86, ARM, Windows, Linux, Mac, etc. In combination with the Bytecode Alliance, we've helped to develop WebAssembly Systems Interface, or WASI, which extends WebAssembly from its initial design of client-side usage to support back-end systems. On top of that, we developed Spin and the Spin SDKs to manage WebAssembly aspects for you, handle complexities around things like HTTP and SSL termination, and let you focus on just writing the code that controls what your function does. So what's this look like in our example today? Well, first, we need to create a Slack app. There are multiple ways apps can interface with Slack, but the one we're going to use today are slash commands. This lets you send a command to an app, have it process the command, and return a result in any channel or direct message. With our app, we need to find our command. In this instance, slash ChatGPT. And the endpoint to which we'll be calling out to, Spin app. We also need to authenticate that request as coming from the appropriate Slack app. Slack provides multiple ways to do this, but today we'll use the simplest, a Slack token. When a user types slash ChatGPT and then some question in a channel, the app will forward the request to the specified endpoint. This is where our Spin app comes into play. Spin handles HTTP and SSL termination for you, handing our function a request, which includes the entire HTTP request. We then need to parse that to do a few things. First, authenticate the Slack token, and second, extract the query. Once we've done that, we build and forward the request to the OpenAI API. This requires another token to authenticate with OpenAI. Now, obviously, we don't want to store these tokens in our code. So where do we store them? Spin provides a couple options, including passing it in as an environmental variable, configuring it in your spin.toml. But in this instance, we're going to use a built-in key value storage. This provides a simple way for us to separate the secrets from the code. Once ChatGPT has processed our query, it returns a response, which we then simply extract the answer from and enter it into the body of the return for our function. Send that back to Slack. Slack will then enter the response into the channel. This might all seem simple enough, but where do we host this Spin app, and how much overhead does that add? Now, we have several choices here as well. Locally, I can run Spin up and to launch my application. But typically, this is reserved for testing, and in this instance, we really don't want to have our laptop open to the world and run this forever. We'd also have Spin apps on Kubernetes via shim. This shim is now included with a preview feature in Azure AKS and with a preview version of Docker Desktop. Alternatively, you can install it into any cluster you are managing with either custom nodes or a daemon set. In this instance, though, we're going for a third option, Fermyon Cloud. Our goal is to build the easiest place to host Spin applications, with the ability to go from blinking cursor to in an empty directory to a deployed application in less than 2 minutes. With Spin and Fermyon Cloud, you too should be able to get a Slack GPT bot or other workload running in no time. Let's go take a look at the code and see this all in action. Great, so let's dig into it. If you're following along and you've not already installed Spin, go get that installed. You can grab that from releases on our GitHub, find the latest version and the appropriate architecture for you. Once you've got that downloaded, just unpack it into your path somewhere. You can see I've got on user local bin Spin. We run Spin. Spin's a pretty straightforward command line utility. We can see the help here. Spin includes a bunch of templates to help us get started and make this very easy and fast. So I can do Spin templates list, and I see the various templates we have. See, a lot of these say HTTP, some of them say Redis, and there's a couple other ones in here. HTTP and Redis are talking about specific handlers that we have. So with HTTP, we're taking in an HTTP request. We're listening on an HTTP port. We're going to pass that request to the function that you've got, wait for you to return a response, and we'll return that. Redis, likewise, we're going to do this with Redis. Redirect is pretty self-explanatory. And then static file server, if you just want to host some static files, you don't have to actually go write your own handler for how to do that. But to return those, we have already created one for you. So you can just use ours and configure it appropriately to point it wherever your files are. So let's go create a simple one here. Oh, I should mention, we actually run the entirety of the Fermyon website on Spin using a project called Bartholomew. A little more complicated than static file server, but you can host any kind of application with complexity of that easily with Spin. So let's do some new applications. Spin, new, HTTP, Rust. Hello, hello, webinar world here. And then we've created this new URL. CD into there. First file we want to look at is the spin.toml. This is in every Spin application, and it's a configuration for Spin. We can see first the trigger and the base here. So we have to have some kind of trigger. That's when we know the Spin app is being triggered. Again, we're using HTTP in this configuration, and we're going to trigger on anything off of the base URL if you hit the URL that's listening onto. And then each Spin app can have multiple components. This one happens to only have one, but we'll see an example later that has more than one. You can see first here the WebAssembly, right? You have to tell us where the WebAssembly is. And then we have allowed host. WebAssembly by default doesn't allow you to do anything, so or at least externally. So we have to go give it access if we need to go talk to something. In this instance, it's hello world. We don't need to. Then we have the trigger route, just like the base trigger here. I can go define what this is going to trigger on. In this instance, it's going to trigger on anything, go with a triple dot. But I could have a one for like /API, /static, and I can have multiple components that are triggered on different routes. And then finally, if you're not using a pre-built WebAssembly that we provided, like static file server, you need to tell Spin how to go build that. And so we've, in each of these templates, pre-populated whatever the command is for that particular language to handle the build. And so let's actually go look at the code itself. So first thing to pay attention to, Spin SDK. This is, again, one of our big advantages. It makes us so much more simple as we handle all of this stuff outside of handing you the request and you just build in a response. So that really allows you to come down here and write just your function that takes in the request, returns a response. This one's super simple. It's just a hello world example, or in this instance, hello webinar. So save that file, and now I can do a Spin build. How long this is going to take is depend on the language and the complexity of your application. Rust tends to take longer to compile because you get better performance. Python's pretty much immediately here because it's just adding the interpreter. So now we can go Spin up, and we can run this thing locally, and I can see, hello webinar, we're running, great. Now I can go about putting this into the Fermyon cloud and hosting this on the internet. So I can do Spin login, which will allow us to log into the Fermyon cloud. And I put in this key and I authorize, and now my command line is authorized to deploy to the cloud. And then I can do Spin deploy. And we wait a few seconds here, and then this thing should be ready. And there we go. And tell us the route. And we can see, hello webinar, we're up and running. Cool. All right, so let's go talk about the more complicated example, the reason we're here today in the first place. So we've got the Slack ChatGPT. Again, previously showed you the URL to get to that. If you didn't have it before, it is github.com/riskmanagement/Slack GPT. I'll also provide a link at the end of this to that and all of the other calls to actions so that you can get back to this if you need to. So let's go look through this application. First, again, let's start at the spin.toml. A little bit more complicated here. First thing you're gonna notice is different. I've got these variables defined. I mentioned in the Lightboard section that we're going to be using KV when we actually deploy this out of the cloud, but we show this application supports as well using configuration here, and then passing this in as environmental variables to configure these, which we'll actually show here in a second. And then I have my first component. Here, instead of using Rust like we were in the last one, we're using some JavaScript here to build this application. So you see this is the actual application that gets compiled. And then allowed hosts, because this thing needs to reach out somewhere, I have to tell it that it has access to reach out and where that is. In this instance, it's the AI for OpenAI API. And then because I want to use a key value store, I have to give it access to that. Just because I define the variable up top doesn't mean that it has access at the component level. So I have to go provide it here in the configuration and then define where it's going to trigger off. And then provide the appropriate command to go do the build. I also have a second component on here, which is our KV Explorer. I'll show you what that is here. We can see this is something pre-built. I'm just grabbing this off of Radu, our CTO's GitHub, and able to run the service and hand it access to the KV store as well. So let's look at the code itself. So again, now we're in JavaScript instead of in Rust, but you can, or it's TypeScript instead of in Rust, but you can kind of see some similar ideas here, right? So we're pulling in the Spin SDK, and that's where a lot of the Spin magic comes from. Because I need to talk to OpenAI, I'm grabbing a library to handle that for me. And then again, I have very similar, I'm creating a function that's really just handling, it's taking in the request, and the promise is a response. Cool. So now how do I go about turning my request into my response? Well, first off, I need these two keys that we talked about. And so I'm going to go try to find those somehow. First, if I have that still configured to the default value of end for in there, because I have not passed something as a configuration through the Spin configuration, then I want to go open the KV. And then we're going to go grab that from the KV, right? Otherwise, we will use the configured value if that configured value does exist. Same thing for Slack. After I've done that for Slack, remember the first thing I want to do with Slack is authenticate that there's actually my Slack app that's talking to us. I don't want to go put this out on the internet and then everyone's using my OpenAI key, and then you charge my credit card $1 bajillion for all of the requests. So let's authenticate this appropriately to our right Slack app. So we're going to go grab the body out of the request, and out of that, I need to grab the token. And I'm going to validate that the token there matches the token that I have configured here. Next, we're going to configure the OpenAI so that we can open the connection. And then we're going to grab the text out of the body. If we don't have any text, if there wasn't a request or something, I'm going to throw an error. And then finally, we're going to go create the chat here with the prompt that I have and send that whole thing here to OpenAI to ask it to respond to us. We're going to wait for that response, handle some errors if it doesn't actually work. And then once I get the response back, I'm going to return the response here, and then ultimately return that response as a return for my whole function, which sends it back to Slack, which will then put that into the channel. And then, of course, do some basic error handling. Cool. So now what do I need to do to run this? Well, let's get into that directory here. Because we're now using Rust, or we're using TypeScript, JavaScript instead of Rust, I need a plugin for Spin. You need Spin plugins list, and you see the plugins. I have JS2 Wasm installed. If you don't have this installed already, do Spin plugins install JS2 Wasm here. And make sure it's 0.4.0 and not a prior version. If you need to, I believe it's also upgrade. Yeah, you can run upgrade if you have to get to a newer version. And then I need NPM for this. So if I don't have NPM installed, I should go install NPM. I'll let you Google how to do that. If I do have NPM installed, I need to actually run an NPM install to install things before I can then go run Spin build. Cool. And so now we've created the WebAssembly. So let's spin that up locally. And so now, because this is an API, it's not super useful to go look at it right here. Just throw my invalid Slack token. But I could use something like Postman to send my request to. Here again, I have invalid Slack token. Well, how am I going to configure the Slack token? I can go here and I say export. And I can do spin config Slack token. So this matches what we had in the spin.toml for here. It's just an uppercase version of this with spin config in front of it. And let's call that Slack token foo. And now I can do spin up again. And I can come here and say token equals foo. And now we got further. We're not invalid, but a prompt is missing. So now I can say text, and it's tell me a Kubernetes joke. And send that. It's what you call an all-day Kubernetes workshop, an event container. It's not bad. So, hey, how did this work without the OpenAI key? Well, I cheated and I don't want to show you my OpenAI key. So I already pre-populated that. Same way I just did it with the Slack token, is just spin config OpenAI key as an environmental variable. So cool. Now we can see that this thing is working. Let's go make it work in the cloud and then ultimately make it work in Slack. So if you've not done it, you're going to need an OpenAI key. So if you hopefully have an OpenAI account, create an account, you can go to the keys, create a new key. Don't give it to somebody else. Use that and populate that in here. I need to also create a Slack app. So I've started to create the app already. See, you go to create new app, but I've got ChatGPT. If you scroll down here, there is the verification token that's shown here. I'm not scrolling down because, again, don't want to expose that, but you can go and make sure you grab that verification token because that's the Slack token we need. Then we're going to configure our slash commands. So create a new command, ChatGPT. And now what is the URL? Well, I don't have a public URL yet. I'm running this locally, but we're going to go push this out to the Fermyon cloud. So I'm going to do spin deploy. Well, my local environmental variables that I've done won't push out to the cloud. So how do I manage those? Well, I do key value equal and a key value, and then I do something like Slack token equals whatever it is, and then key value and OpenAI key equals whatever it is. In this instance, I've already pushed it out there because, again, don't want to expose it. So I'm just going to run spin deploy. And let's go see what happens. Give this another little bit to get going. All right, and we're up. So let's copy this URL into our URL here. And let's say, short just go to Slackbot, which queries ChatGPT. And the usage hit is just question here. So /GPT/question. Save. Cool. Now, before we skip to the next step, we should be able to actually see here in my KV Explorer. So this is the other component that I have running. You can see that I've got these two keys already populated in here. You can actually use this to go populate them if you wanted, but ideally in a deployment step, you'd be using that //KV command. And then going to hit stop, open, and grab here. Share my screen again. Let's make sure I'm in the right Slack channel. And now I can try /ChatGPT and tell me a spin joke. I don't know if that counts as a spin joke, but boom, we can see now that it's working end to end. So hopefully this has been enlightening for you to see how we can use Spin to create very quickly an application that ties together several things that, previously, if you're trying to do this in something like Lambda, would require a bunch of different AWS services to provide that end-to-end experience where it actually work, and then more code to actually handle all of this. And then we were able to deploy that out and have that hosted in the cloud with Fermyon Cloud very easily, very simply, and get it running. As I mentioned, Fermyon Cloud isn't your only hosting destination. You could run Spin up somewhere and have just running. We've also seen a lot of people do this with Kubernetes. So we have a Kubernetes shim that allows you to just deploy this to a workload in Kubernetes. And then if you have an existing Kubernetes cluster, existing technology, this becomes just a library instead of, say, a full new vendor. So hopefully this has been helpful for all of you. If you want to learn anything more here, I want to put this slide here so you can let's go boom. Bunch of follow-up information. Follow us on Twitter. Go use our quick start if you haven't done it to get good practice with Spin. You can see more of this project. If you want to get this slide here and you're watching the video, I don't know what happened there. Now, if you want to get that slide, you can just grab it from end the slideshow here. You can grab this QR code and grab this slide here. And those take you to all these links so you don't have to try to type them out. If you have any questions, though, I'm in our Discord. Feel free to reach out. We'd love to chat and answer any questions and hear people's feedback and experiences with Spin and with Fermyon Cloud. So thank you so much. I hope you found this all really useful.